4.4 are to be able to apply side angle side and side 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 to solve problems, and to be able to prove triangles using side 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 and side angle side. Triangle rigidity. It has to do with the similarity. We showed that it forces, if we can show that they're similar by side 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 or side angle side, then it's going to lock the angles in too. There's something called triangle rigidity, which is if you lock in certain sides and angles, not all, but certain ones. In this case, if we lock in the 3 sides, or if we lock in the 2 sides and the angle in between, the others are forced to be the same. So the idea is this. Mr. Ritter gives you 3 sides. One of them's a 3, one of them's a 4, one of them's a 5. And I give you 2 sets of them, and you try to build them. Well, if I build one of them, am I going to be able to build another one that looks different than that one? No. That's triangle rigidity. The lengths of the sides are locked in, and they're only going to be able to connect in a certain way that the angles between when I connect them are going to be the same also. That's triangle rigidity. The same thing with side angle side, and we saw how it is similar when we talked about the front side of these notes, how the similarity will give us the other angles congruent. Side angle side congruent says, or side 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 says, if 3 sets of sides are congruent between 2 triangles, if 3 sets of sides are congruent between 2 triangles, then the triangles are congruent. And then all of their angles will be congruent by CPCTC. But this thing itself, side, 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 it is a postulate. But we don't need to memorize whether it's a postulate or theorem for this. It just says if the 3 sets of sides are congruent, then the triangles are congruent. So in this particular image, we have the short legs, AB and DF, are both 4 units. So those are congruent. We have BC and DE are both 6, so those are congruent. Those are the long leg. And then the hypotenuse of ABC is congruent to the hypotenuse of the other triangle EF. So we've got 3 sets of sides congruent. Because of that, triangle ABC is congruent to, well, I went across the short leg and then the long leg. So for this one, I have to go down the short leg and across the long leg. So I'm going to have to call my other triangle FDE, just like we did when we did similarity statements. Any questions so far? Yes?
So for similarity, you write like a little n. How would you write side, side, side congruent?
So I just would write they're congruent by side, 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 no tilde at the end. The tilde is only for similarity. For our next one, we're going to say that this says if 2 sets of sides are congruent and the included angle is congruent, 2 sets of sides and the included angle, between the 2 triangles, then the triangles are congruent. We've seen side angle side before for similarity. It has to be that this angle touches both of the congruent sides, not only in this triangle, but also in the other triangle. If it doesn't do that, then it's not congruent by side angle side. So in this case, we have I'll even write out the side angle side argument, although we don't normally do that. We're going to be doing 2-column proofs. I have AB congruent to EF. I have angle A, which is sandwiched in between those two congruent sides, congruent to angle E, sandwiched between those two sides. And then I have AC congruent to DE. No. DE. ED or DE, doesn't matter. So those triangles, triangle BAC, this time I went across the single tick mark to the angle and then across the double tick mark, is congruent to FED. Doesn't have to be alphabetical order. It has to have matching order by side angle side. So this is what we are going to use. We're going to add to this some other shortcuts, but basically we use this with our other proof writing vocab from last semester: vertical angles theorem, reflexive property, definition of right angles, definition of perpendicular, right angle congruence theorem. Not definition of right angles, that says that they're 90 degrees. Take a quick second to look at these pictures and see if there's anything in them that you could mark, and just jot down whether you think it's side, 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 or side angle side. So side angle side for letter A, because of the vertical angles, those will be side angle side. What about letter B? Well, the left triangle has side angle side. Does the right triangle have side angle side? Yeah. I need it to be this angle, and I don't have that one, so no. I could do vertical angles, but that doesn't help me. Letter C, is there anything I could mark? See this C piece? That's bireflexive. And we'll talk about that when we get back from lunch, but that one's side, side, side. Have a good lunch. Before we left, we were, you guys decided that this could be side, side, side. I'm going to tell you that before, in the last unit, we had triangles that were similar, and we were using angle-angle similarity. And we could say angle A was congruent to itself by reflexive property of congruency. You don't have to write this down. Well, now we're going to have shapes that maybe share a side. I don't know why I did that. But anyhow, if they share a common side, we can mark those congruent to themselves, right? Because it's a side for both triangles, so it's the same length on both triangles. That now would be by reflexive property of congruency. So instead of using it for angles, we now use it for sides when we're doing congruency proofs. So we're jumping into our first 2-column proof. Given that AB and BD are congruent, C is the midpoint of AD, we are supposed to prove the triangles are congruent. I don't like this picture because they've marked stuff that we don't have in our proof yet, and we really shouldn't mark it off till we have it in our proof. So I'm going to start with the given AB congruent to BD, and C is midpoint of AD. Well, they do have a congruency statement here that AB and DB are congruent, so I will mark those and put a little check mark next to them because they're actually in the proof already. I don't have to make any statements about those sides. But that's the only set of sides I have. What does it mean to be the midpoint? To bisect it or cut it into 2 equal halves. Except if they had said that BC was a bisector, then I would use definition of bisector. But this time they actually said that C is the midpoint. So that does give us these congruent pieces AC and CD. And what reason should I put? Correct. Definition of midpoint. The vocab words that they give you are a hint to get you started. Now the trickier ones are when they give us perpendicular, because if they say perpendicular, I can't say the angles are congruent. I have to say what about the angles first? That they are right angles. And then I have to use the right angles theorem to say they're congruent. So that's the one that's a little trickier. But if it's bisected, I'm going to use the definition of bisector. If it's a midpoint, I'll use the definition of midpoint. I can always look for vertical angles or angles formed by parallel lines if they tell me there's lines parallel. So right now we have 2 sets of angles checked off in our picture, actually sides, not angles. What else can I mark in the picture? BC is congruent to BC because of definition. No, not definition. You were right. Reflexive property of congruency. So I'm going to mark that BC congruent to itself, and I can check that off. Now, if I look at the left side triangle, I have 3 sides marked, and those are in the proof. Right side triangle, 3 sides are marked. Those are in the proof. So why are the triangles congruent? Side, side, side. So they're easy today because it's either side, side, side or side, angle, side, and no other combinations. We will have at least 3 or 4 more that we can look at tomorrow. Yep. In our next proof, it says that x, v, and wy bisect each other. So I'm going to write that down. X, v, and wy bisect each other. That's our given. That's all that's given. We're supposed to prove the triangles are congruent. Well, what does it mean to bisect each other? Yes? That their pieces are equal. So they're cut, both of them, each of them is cut into 2 equal pieces. So xv has been cut into 2 equal pieces because it's been bisected. And those pieces are xz, which will be congruent to zv. And since they bisected each other, wy was also bisected. It was cut into 2 equal pieces. Those equal pieces being wz and zy. What reason will I put for that? Definition of bisector. Or definition of segment bisector to be more specific, but definition of bisector is fine. It was segments that were bisected, so we wrote about the pieces of those segments being equal. They don't have any other given information to help us, but there is something else we can mark in the picture. Raise your hand if you know what it is. 3 people see it. Everybody should have seen it after the very first unit of geometry. Carly, what do you think? Vertical angles, absolutely. Can I call them angle Z? Nope, there's 4 angle Z's there. They all have the same vertex, so I got to go angle XZY or YZX, it doesn't matter, is congruent to WZV or VZW by vertical angles theorem. So we have 2 sets of sides written as congruent. We have the angle, and it's the angle that touches those, sandwiched between those 2 sides in the bottom triangle, sandwiched between the 2 sides in the top triangle. So triangle XZY is congruent to triangle VZW by side angle side shortcut. Take a moment to see if you can figure out what you could mark in the proof for letter C and whether we would use side, side, side or side angle side. All right, so in this proof, because of the parallel lines, I'm just going to circle all this and put it as number 1 given. We have to be careful, though, when we go to mark which angles we're going to use with the parallel lines. They have to be connected by the parallel lines. There is another set of alternate interior angles here. If I followed these lines, this angle right here under vertex B and above vertex D, those are also alternate interior. But they're not with the lines that we were given as parallel. They were given with the other lines. So I can't say anything about those because those lines weren't given as parallel. However, with that letter Z, I can mark angle ADB and angle CBD congruent. And that was, like you guys said, alternate interior angles theorem. They did give us a set of sides. That's already in our proof. It is in line 1. I'm going to write it just so I can see it, because otherwise I'll forget that it's there. So they have this, and they've marked it for us. It was a given. And then you guys said BD is a shared side between the two triangles, so it is congruent to itself. By reflexive property of congruency. Yes?
Number 2, why is it CBE?
Well, it could be DBC. So the angle has to be this angle right here in the corner up made by the Z with the parallel lines, and this one right here. It has to be those two corners. It cannot be the one above the D, even though that's also alternate interior. That's formed with line CD and AB.
Yeah, B is the vertex.
Oh, shoot, it should have been ADB. This one's wrong. This should be ADB. Yeah, the vertex had to be D there. Thank you. Yes?
Could you switch steps 2 and 3?
You can. In this case, as long as the given had the parallel lines came first, these could happen in either order. But our last line has to be our last line, and that is that the triangles are congruent by side, angle, side. Take a moment to see what you think, mark it in pencil if you're going to mark it, what you think we can mark in proof D. All right, so I've had a range of answers here. What was bisected? What was bisected, Macy? RQS. I'm going to trace that or highlight that because that's not why these are marked congruent. These are marked congruent because of this congruency statement. Okay? So I've got all of this given information right here. But these were congruent not because the angle was bisected. What does it mean to bisect? To cut into two equal pieces. So up here, when the segments were bisected, it created, because it bisected a segment, it created two equal segments. What happens when an angle is bisected? Two equal angles. And so those angles are RQP, this angle, and SQP, this angle right here. So based on the word bisects, and the fact that it was this angle that was bisected, not a segment this time, but an angle, angle RQP is congruent to angle SQP by definition of angle bisector. If you just put bisector, that's okay too, but make sure that you know it's the angle that was bisected, not a side. I've had a lot of people who thought RP and PS could be marked congruent, but it's not. If it were side RS and P was in the middle and RS was bisected, that would be the case. RS wasn't bisected. The angle RQS was. What else can be marked in this picture? Yes? QP is a shared side. So we always look for vertical angles because they're not going to be given in our proof. We always look for shared sides. They're not going to be given in our proof. We're going to just have to put them in by this one by reflexive. QP is congruent to QP by reflexive property of congruency. And so if I look at the triangle on the left side, I've got an angle sandwiched between two marked sides. On the right side, an angle sandwiched between two marked sides. Those sides are recorded as congruent, so is the angle. So triangle RQP is congruent to triangle SQP by side, angle, side.